Hi all and welcome back to our channel Nursery to Veracity. In this tutorial we are going to study data structure vector and its practical implementations. Data structure vector in R. We know that we have total 6 types of data structures. They are vectors, matrix, arrays, data frames, list and factors. In this video we are covering what are vectors and how we can practically implement vectors into our R Studio. Right. What is vector? Number one, vector is a basic data structure in R. Number two, it contains element of same type. That means a vector contains either all the elements of the logical type or all the elements of the integer data type or all the elements of the character data type or of the complex or of the numeric. So the data types can be logical, integer, double, character or complex. Now, number 4, a vector's type can be checked with type of function. Number 5, another important property of vector is its length. So, we can check length of a vector using the length function. Now, let's see how we can practically implement it into the RStudio. Coming to the integer vector, I've taken int as my vector name and using the C function I'm storing my integer values. We have taken capital L suffix over here as earlier discussed. It is used to tell R that these values are of integer data type, right? I've used colon operator in order to enter my values in sequence. So we are running the statement and we can see that in int we have values 1 to 71 and 30 and in int 1 we have sequential values 1 to 5. So we'll run this statement and we can see the values. Now coming to the class function, as you know that the class function tells us which class the particular element belongs to. Now we have taken int vector. In order to know which class this int vector belongs to, we'll run the statement and we can see it belongs to integer class, integer data type, right? Now, type of function helps us knowing the subclass of a particular element. For example, I'm running this statement, this type of, and I can see that in integer, the subclass is also integer. So, these are the elements, they belongs to class integer and subclass integer. Now, coming to the numeric data type, we can see that we have taken values 1.3, 2.4. We have taken decimal values to be stored into our num vector and have taken numeric vector named as num. So we'll be storing these values and also we have taken 1, 3, 4, 5 values to be stored into our num1 vector. So we'll run the statement and we can see that values are getting stored into this vector num1. Now in order to know the class or which type this particular vector belongs to, so we'll run the statement and we can see that num vector belongs to numeric class, numeric data type, right? Now in order to know the type, that means the subclass of this num vector, we will run the statement and we can see that the subclass of the vector, numeric vector, belongs to double, right? Let's see which type num1 elements belongs to. It also belongs to the double data type. In order to check the length of a vector, we have to use length function. And this length function will tell us the number of elements that are present into our vector. So I wanted to check the number of elements into my num vector. So we will run the statement and we can see there are total 3 elements into my num vector. So this is very easy. You can try it by yourself. In case you find any issues, you can write comment into the comment box and we'll be there to help you. Now coming to the logical vector, we have taken vector name as log. We are storing values as true, false, true, true. We have 2 logical values, true and false. So we are storing these values using the C function into our log vector. So by running the statement, we will be storing these values. And now we need to know the class of this log vector. So we'll run the statement and we can see that the class of the log vector is logical. The element belongs to the logical data type. Now coming to the type of log, that is the subclass, and the subclass for the logical is the logical only. So we are getting our value as logical. Now coming to the character vector, see, you can see that I have taken character into double inverted commas because if we want to store our character value, we need to use double inverted commas. And you can see I can use even a single word or the group of words or a single character into my one vector only, right? So I've taken char as my vector, and using the C function, I'm storing my values. We'll run the statement for the character data type, and we can see we have 4 elements, and the class which it belongs to is of the character data type, right? Now, what is the subclass of the character? It should be character only. So we'll run the statement, and the subclass is character only. And the length, number of elements that are present into my char vector are 4. They are hi, hello, today is a great day, and capital A. Now coming to the complex vector, we are storing the complex values again using our C function, and complex value contains real part and the imaginary part. So we'll run the statement, and we can see that our comp vector contains the above mentioned values. And now coming to the type of comp belongs to complex data type. See, so it's very easy, try it by yourself. And we'll go again to this slide, and we can see what 6 statement says. It says, in order to enter values in numeric vector, we can use either the C function or the colon operator, or we can call it as range operator. In C function, you have a leverage that you can store any random values. That can be 1, 5, 7, 8, 10, any random values. But when you are using colon operator, you will be storing values in a sequence wherein you are giving your first value and you're giving your last value. And when you'll be storing this value into this X, it will be storing values 1, 2, 3, 4 and 5, right? So we have already seen its practical implementation now. Coming to the next point, all the arithmetic operations can be performed on numeric vector. So let's have a look how we can perform arithmetic operations on the numeric vectors. Coming to the arithmetic operations, I'm taking my vector num1 wherein we are storing some numeric values, and we are taking vector num2 wherein we are storing some other numeric values only. Now we are performing addition operation on 2 vectors. So we will see that we are performing the operation, and we can see the operation has been successfully performed, like num1 plus num2. So it will add index 1 value to the index 1 of num2 and index 2 value of num1 to the index 2 value of num2. Like 3 plus 1 is 4, 3 plus 4 is 7, 5 plus 4 is 9, and 9 plus 5 is 14. So it's very easy to perform the arithmetic operation on numeric vectors. Now we'll take vector named as num1 only. Now let us add one more element to num1 vector. You can see the length of the 2 vectors are uneven. They are not same. Let us run this statement. We can see that when we will be performing the arithmetic operation on 2 vectors of different lengths, so what will happen now? We are getting a warning that says that longer object is not a multiple of shorter object. No worries, there is no harm. We can still add. So we can see 3 plus 1 is 4. 3 plus 4 is 7. 4 plus 5 is 9. Now 5 plus 9 is 14. Now what is to be added to 4 so that we can get 7? When we have 2 vectors of different lengths, the vector with the shorter length starts repeating itself till the number maximum we have in the larger vector, right? In larger vector we have 5 elements, but in smaller vector we have 4 elements. So it will repeat its first element again, and it will add 4 with 3, giving us the result as 7. So when we have 2 vectors of uneven length, the smaller vector will repeat itself till the maximum length of the first vector, right? So it is very easy to perform this operation. You can try it by yourself, making such conditions and all. Now coming back to the slide, after numeric vectors allows manipulation of logical quantities as well. Logical vectors are generated by conditions. So let's see what are the conditions. Here we have assigned value 5 to our vector x, and we are manipulating logical quantity. How? We have taken x and value is 5, and we are comparing x with 13, whether 5 is greater than 13. So whatever value comes will be entered to our temp variable, right? So logical vectors are generated by condition. This is the condition wherein we are generating our logical vectors. So we will come to the practical implementation, manipulation of the logical quantities. The same example we are again using here. So we are running the statement and using the temp, we can see that the value that has been assigned to the temp variable is false. That means x is not greater than 13. So this is how we do the manipulation of the logical quantities, right? So this false value, that is the outcome of this statement, is getting assigned to the temp variable using the left assignment operator, right? So it's easy, right? Now coming to the next statement, there are some cases where the components of vectors may not be completely known. That means when there are values which are not completely known, they are either the unknown values or the missing values. For unknown or missing values, our vector uses NA, that is not applicable. Coming to the next statement, is.NA is the function that tells us whether there is any NA value present in the vector or not. So since we struggle with lot many data in our data science or data analysis, at that point, if you're performing some actions and you're not getting a particular answer for that, or you're getting some NA values, why we are getting some NA value? That means there must be some NA value present in your data, and in order to know which data contains the NA value, you can use the function is.NA, right? Next point says any operation performed on NA will become NA. That means when you have some missing value and you perform any operation with this missing value, so the resultant you will get is NA, since vector uses NA in place of any unknown value or the missing value. Let's see how this works in R. We have taken num3 vector. Using the C function, I'm assigning the values wherein I have one unknown value. I don't know what's there in this particular value, so I'm using NA. I'm running the statement num3. Let's see what we get in num3. We can see that we have one value that is unknown to us. Now we wanted to perform addition arithmetic operation on num1 and num2. After performing this arithmetic operation, we can see that if we'll add value, 1 with 3 will get a 4, 2 with 4 will get a 6, NA with 5 will get NA only, right? And 5 with 9 is 14. This proves the statement that says any action performed on NA will give the result as NA only, right? Now, in order to check whether we have NA value present in a particular set of data, we can use is.NA function. In this, we are using the vector name as num2. We want to check whether the num2 contains any NA value or not. Now, we will run the statement. And we can see false, 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 false. That means we have 4 values in num2. That is 3, 4, 5 and 9. And no value is NA. So at every point we are getting false as our resultant. Now we wanted to check whether we have any NA present in our num3 vector. So we will perform is.NA function. And we can see we are getting false, false, true and false. We are getting true at the third index value of our num vector. So the third position of this num3 vector is containing NA value, right? By using is.NA function, we can check whether the particular set of elements are containing any NA value or not, right? Now coming to the next point, the character vectors are always denoted by sequence of character delimited by double quotes. So we already know that when we store any character vector, we enter it with double quotes, right? So we have already performed this. We have seen the practical implementation as well. Coming to the next point, in order to search value at a particular position or range in vector, there is a need for index vector. If I wanted to know what my vector contains at its 5th position, in order to know the particular value at the particular position of a vector, we need index vector. That tells us what our vector is containing at a particular index position. For example, I have a vector ranging from 10 to 20. So what is the value at my third index? So starting with 10, we have 10, 11 and 12. 12 is the third position value in the range 10 to 20, right? So looking into its practical implementation, we have index vector. Now we are taking num vector. So here is the num vector and we wanted to know the position or at what position our vector contains what value. Second position of the num vector, what is the value? So we have 2.4. That is the second position of the num vector. Now, if I wanted to know what is the value present in my num3 vector at its third position, so in my num3 vector, the third position is NA, right? Let us see what we get. Now running the statement, I can see that in my num vector, the third position is NA. That is unknown value, so it will give me NA only. So index vector helps us to know what is the value present at what position of the vector, right? That's all in the vectors. We have already studied the practical and the theoretical part. It's your time to try, and I'm giving you very basic ideas, and we are performing each line practically as well. So more and more you work practically, more and more the knowledge you will gain. I hope you like this video and study hard, guys. Do the practical implementation. Also, if you find any issues, you can write the comment in the comment box, and you can email us on nur2var@gmail.com. Thank you, guys. Thanks for watching our video. Stay tuned. Please like, share and subscribe. Do press the bell icon to get the latest update. And you can also follow us on Facebook, Instagram, Twitter and LinkedIn. And for any queries, you can email us on nur2var@gmail.com. Thank you.